William Gilbert of Colchester, physician of London, on the Lodestone and magnetic bodies, and on the great magnet, the earth, a new physiology, demonstrated with many arguments and experiments. A translation by P. Fleury Motile, author of The Chronological History of Electricity, Magnetism, etc. Electrica que atrahunt iadum ratione ut electricum. London, Bernard Quaritch, 15 Piccadilly, 1893. All rights reserved. Ferris Brothers Printers, 326 Pearl Street, New York. The image is the rod of Asclepius, a T-shaped cross with a serpent beaked surrounding it, held by two hands which come out of clouds. The next sigil is of a coat of arms topped by a griffin, traditional British four corners, with what seems like bears or lions, 6 of them, and another sigil I can't understand or know, but there are blue flowers, 6 of them. The sigil I didn't know may be clam shells or oyster shells. 1, 2, 3, 4, 5, 6, 7, and then a half. Surrounded by tassels and water. And a knight's shield. Translators Preface. I first entered upon the translation of this, the earliest known published work treating of both magnetism and electricity, in the beginning of 1889. It was then my intention to place it before the public during the year following, appreciating as I did the demand for an English version which had been frequently reiterated by scientists generally in this country, in England, and upon the continent of Europe. But the attention I was compelled to give, both here and abroad, to the preparation of my chronological history of electricity and magnetism has unavoidably delayed the publication of the present volume. The translation of De Magnete has been a task of no ordinary difficulty. It has brought up problems innumerable, the solution of which has involved much laborious research, as the result was meant to be a clear and competent presentation of the author in idiomatic English, and not simply a substitution of English words for Latin. Nor would I have ventured to appear as the English interpreter of the great Gilbert, father of the magnetic philosophy, but for the hearty encouragement of the very material aid in translating and otherwise extended by many literary and scientific friends, amongst whom must be especially mentioned Mr. Joseph Fitzgerald, Mr. E. Macmillan, Mr. Joseph Wetzler, Dr. Joseph V. Livingstone, the Honorable Park Benjamin, and Professor Alfred M. Mayor. I am likewise indebted to Professor Charles Sanders Peirce, to Mr. Latimer Clark, FRS, to Dr. Isaac H. Hall, and to Dr. Charlton T. Lewis for valuable suggestions as to the general treatment of the work, and, in the words of the celebrated English mathematician Edward Wright, I doubt not that our united efforts will find the heartiest approval among all intelligent men and children of magnetic science. Not only does Gilbert frequently make use of what he terms words new and unheard of, besides attaching to many others a signification far different from that generally recognized at this day, but what is worse, he retains to a great extent the terminology of the medieval scholastic philosophers. That terminology the translator must perforce retain. No substitute is possible. Hence is found a multitude of uncouth words which, for the modern reader, require explanation. Of such it is unnecessary here to make any special mention, since the copious general index to the present work will indicate very readily where they are to be found. It is known that in the philosophy of the schoolmen, as in that of Aristotle, from forma means that which added to matter, materia, constitutes the true nature of the living thing. Matter per se is indifferent, indefinite. Form gives its definiteness. The earth is informed with verticity. That is its prime distinction. When any portion of the earth loses verticity, it loses its forma, is deformate. To restore to its verticity is to reformat it, or to informat it. Portions of the earth that are deformate are as were effete, excrementitus, waste matter. Gilbert states, Book 2, Chapter 2 and 4, that the natural magnetic force, movement, comes from the prime forma of the earth, or rather the primary native strength, vigor. Elsewhere he tells us that the earth and the lodestone conformant magnetic movements, Book 2, Chapter 6, and he speaks of substances conformatum, by the earth, Book 3, Chapter 4, and of the globe of earth as a small account and deformatum, Book 5, Chapter 2, Book 5, Chapter 12. He speaks besides of the formate, soul, formata, anima, Book 5, Chapter 12, of air or water being informated, by magnetic forms or spheres. Book 5, Chapter 11, of iron being transformated, Book 3, Chapter 12. And he adds that iron will attract more properly if it is afformed, Book 2, Chapter 4. Also that it will be better if the iron's acquired verticity be by some process rather weakened or deformata. Book 3, Chapter 11. England's great poet, John Dryden, tells us it is almost impossible to translate verbally, and well at the same time, for the Latin, a most severe and compendious language, often expresses that in one word which either the barbarity or the narrowness of modern tongues cannot supply in more. But since every language is so full of its own properties that what is beautiful in one is often barbarous, nay, sometimes nonsense in another, it would be unreasonable to limit a translator to the narrow compass of his author's words. It is enough if he choose out some expression which does not vitiate the sense. While, in order to do this acceptably in the present instance, it has often been found necessary to adhere very closely, even literally, to the original lines, the candid reader will naturally observe that great satisfaction has been vouchsafed, where paraphrasing has been resorted to for the better comprehension, more particularly of words of Gilbert's own coinage. Following Dryden, I have translated with latitude, keeping in view the author's sense more particularly than his words, and amplifying without altering the former. Nor have I, in so doing, attempted any more than did Gilbert, to impart into the work any graces of rhetoric, any verbal ornateness. Like him, I have simply endeavored to treat knotty questions about which little is known in such style and in such terms as are needed to make what is said clearly intelligible. Such few passages of De Magnete as I have seen independently translated elsewhere will be found reproduced in their proper places, and wherever predictable I have followed the approved plan adopted in my chronological history of quoting numerous authorities and inserting many extracts from the writings of different authors in support of the original matter. The extent to which this has been done is shown in the general index accompanying the present work. I may add that I shall be under obligations to those calling attention to any errors, typographical or otherwise, that may be found herein, as well as to those whose helpful advice may make improvement possible in future editions. P. Fleury Motelet, New York, March 10, 1892. Biographical Memoir. William Gilbert, or Gilbert, as he wrote it, was born in 1540 at Colchester, County Essex, England, of which borough his father, Jerome Huron Gilbert, was recorder, a consular of great esteem in his profession. Very little, that is, reliable appears concerning his early years, but it is known that he passed through the grammar school of his native place, and immediately afterwards, May 1558, entered St. John's College, Cambridge, whence some say he went to Oxford. Proceeding B.A. 1560, Fellow 1560 to 61, M.A. 1564, Mathematical Examiner 1565 to 1566, M.D. 1569, and being elected a senior fellow of St. John's during the last named year. For notes, Gilbert or Gilbert, the latter is used both in his own epitaph and his father's, and in the records of the town of Colchester, and therefore seems the truest. Biographica Britannica, London, 1757, Volume 4, page 2202. See the map of Colchester at page 4, Volume 1, Book 1 of Philip Morant's History and Antiquity of Essex, London, 1768, also a full description of the town at pages 266 to 361, Volume 1 of Thos Writes, History and Topography of the County of Essex, London 1836, as well as at pages 286 to 322, Volume 5 of The Beauties of England and Wales, by E. W. Brayley and John Britton, London 1810. Dr. Thomas Fuller, History of the Worthies of England, London 1840, page 515. Anthony A. Wood, at pages 737 to 738, Volume 1, Athenae Oceaniensis, London 1813, says he was educated at both the universities, but whether in Oxon first or in Cambridge, I cannot justly tell. In Thomas Wright, History and Topography of County of Essex, 1836, Volume 1, page 311, states that he studied sometimes in the universities of Oxford and Cambridge. Continuing, immediately upon leaving college, he traveled on the continent, where probably he had the degree of Doctor of Physic conferred upon him, for he doth not appear to have taken it either at Oxford or Cambridge, and where, as well as in England, he is said to have practiced as a physician with great success and applause. In 1573, he was elected a Fellow of the Royal College of Physicians and filled therein many important offices, becoming in turn Cincture 1581 to 1582, 1584 to 1587, 1589 to 1590, Treasurer 1587 to 1591, 1597 to 1599, Consilarius 1597 to 1599, and President 1600. His skill had already attracted the attention of Queen Elizabeth, by whom he was appointed her physician in ordinary, and who showed him many marks of her favor, besides settling upon him an annual pension, said to be the only legacy left by her to anyone, for the purpose of aiding him in the prosecution of his philosophical studies. Gilbert's removal to court led to the dispersion of the members of a society or college which, it appears, frequently met at his residence at Colchester. See illustration. This house, anciently known as Lancelles, Temporales, Tempornelles, Old Taxation, was located on St. Peter's Hill between Upper Thames Street and Little Knight Ridder Street. The early investigations of Gilbert were centered almost exclusively upon chemistry, he attaining to great exactness therein, but this branch was ere long made to yield to the study of the phenomena of electricity and magnetism, the latter of which had practically lain dormant for 2,000 years, since the days of Thales and Theophrastus. A note, Philip Morant, Locite, Volume 1, Book 2, page 117. See likewise Rees, R-E-E'(S), Cyclopedia, 1819, Volume XVI, 16, article Gilbert. Returning. How well he succeeded in generalizing and classifying these phenomena. After a patient and exhaustive line of experiments, is best evidenced by the great work which he published during 1600 under the title of De Magnete Magnetisque Corporibus et de Magno Magnete Tellure, Physiologia Nova, Plurimis et Argumentis et Experimentis Demonstrata. There's a photograph splitting this paragraph. Gilbert's house at Colchester. It is a 2-story house, 3 window lengths down, quite a bit of space between the second and third, with it seems like an attic where there were at least 2 windows, possibly for rooms, and bushes and an archway door, very similar to a version of the 10 of coins card in the Wizard's Tarot. This book, full of valuable facts and experiments, ingeniously reasoned on J.F.W. Herschel, upon which Gilbert was actively engaged during 18 years, in his best claim to recognition as the most distinguished man of science in England during the reign of the Virgin Queen. The year 1600 observes the English historian Henry Hallam was the first in which England produced a remarkable work in physical science, but this was one sufficient to raise a lasting reputation for its author. Gilbert, a physician, in his Latin treatise on the magnet, not only collected all the knowledge which others had possessed on the subject, but became at once the father of experimental philosophy in this island, and by a singular felicity and acuteness of genius, the founder of theories which have been revived after a lapse of ages, and are almost universally received into the creed of science. Gilbert was one of the earliest Copernicans, at least as to the rotation of the earth, and with his usual sagacity inferred before the invention of the telescope that there are a multitude of fixed stars beyond the reach of our vision. Gilbert's book created a powerful impression at the time, especially among the learned in other parts of Europe. Galileo expressed the highest admiration of the work and of its author, and it is said pronounced Gilbert great to a degree that is enviable. It was indeed by the perusal of De Magnete that Galileo was induced to turn his mind to magnetism. In his own country, Gilbert was scarcely so highly appreciated. Even Bacon, though he praises Gilbert as a philosopher, speaks with little respect of his theory. After a while, his speculations came to be more esteemed, though perhaps not fully understood, but the great superiority of Gilbert over all who had previously treated of magnetism, and the extent to which he had anticipated by his conjectures most of our present knowledge, has only been perceived since the study of magnetism has assumed a something like its present systematic and comprehensive character. Notes: Introduction to Literature of Europe, or Introduction to Lit of Europe in the 15th, 16th, and 17th centuries. London, 1839. Volume 2, page 463. Dr. Monk, Roll of the Roy, College of Physics, Roll of the Royal College of Physics, 1878, page 78. Continuing. While Dr. Huiguel observes that Gilbert's work contains all the fundamental facts of the science, so fully examined indeed that even at this day we have little to add to them, Dr. Thomas Thomson says that De Magnete is one of the finest examples of inductive philosophy that has ever been presented to the world. It is the more remarkable because it preceded the Novum Organum of Bacon, in which the inductive method of philosophizing was first explained. How far Gilbert was ahead of his time is best proved by the works of those who wrote on magnetism during the first few decades after his death. They contributed in reality nothing to the extension of this branch of physical science. Poggendorff, from whose Geschichte der Physik, page 286, this is extracted, calls Gilbert the Galileo of magnetism. By Dr. Priestley, he was named the father of modern electricity. In an article written not long since, Mr. Conrad W. Cook of London notes the high opinion of Gilbert's work entertained, more particularly by Nathaniel Carpenter, William Barlow, Francis Bacon, Galileo, and Humboldt, and he adds, there is abundant testimony extant that this De Magnete of Gilbert's produced a profound sensation, not only in this country, but throughout the then civilized world, and it is a singularly curious fact that the brilliancy of a reputation so great and so original should have been allowed in subsequent generations to have been lost sight of in the more blinding light of more recent knowledge and discoveries, and it is equally remarkable that a book so classical in its nature, so remarkable in its originality and prescience, and which was thought so much of during the periods which immediately followed its publication, should never have been translated into English, or indeed into any other language, and this is rendered still more curious by the fact that such a translation was actually called for at the time, and the want of it was considered remarkable as far back as the year 1618. And here it will be interesting to quote from the preface to a scarce old book, Magnetical et Verticimos, written at the date by the Venerable William Barlow, Archdeacon of Salisbury, and a very intimate friend of Dr. Gilbert. Many of our nation, he says, both gentlemen and other of excellent wits, and lovers of these knowledges, not able to read Dr. Gilbert's book in Latin, have been, ever since the first publishing thereof, exceeding desirous to have it translated into English, but hitherto no man hath done it, neither to my knowledge as yet goeth about any such matter. Whereof one principal cause is that there are very few that understand his book, because they have not lodestones of divers forms, but especially round ones. And the author gives a further supposition that a second cause may be for that there are divers words of art in the whole course of this book, proper to this subject, and fit to the explication of his figures and diagrams, which cannot be understood but by the help of mathematics and good traveling in the magnetical practice. Notes from various pages. English Cycle Section, Biography, Volume 3, page 102, History of the Inductive Sciences, 1859, Volume 2, page 217, History of the Royal Society, London, 1812. Speaking of William Barlow, Anthony A. Wood said this was the person who had knowledge in the magnet 20 years before Dr. William Gilbert published his book on that subject, and therefore, by those that knew him, he was accounted superior, or at least equal to that doctor, for an industrious and happy searcher and finder out of many rare and magnetical secrets. Athena Oxenisis, London, 1813, Volume 2, page 375. Under heading of Gilbert, the British Museum Catalogue of Printed Books, 1888, has its magnetic advertisement was compiled partly from De Magnete. Dr. John Davy says Gilbert's work is worthy being studied, and I am surprised that an English edition translation of it has never been published. He also alludes to the well-known reproach thrown upon Gilbert's philosophy by Francis Bacon, who in his De Augmentis Scientiarum remarks that Gilbert has attempted to raise a general system upon the magnet, endeavoring to build a ship out of materials not sufficient to make the rowing pins of a boat. On the other hand, Digby and Barlow place Gilbert upon a level with Harvey, Galileo, Gassendi, and Descartes, while the celebrated historian of the Council of Trent, Father Frater Paolo Sarpi, who will not be thought an incompetent judge, names Gilbert with Francis Vieta, the greatest French mathematician of the 16th century, as the only original writer among his contemporaries. Notes: Memoirs of the Life of Sir H. Davy, London, 1836, Volume 1, page 309. Novella Biographie Générale, 1858, Tome 8, page 494. Lettere di Frater Paolo, page 31. Hallam, Introduction to Lit, 1839, Volume 2, page 464. It is deserving of notice that Gilbert was the first to use the terms electric force, electric emanations, and electric attraction. He it was also who gave the name of pole to the extremities of the magnetic needle, pointing to the poles of the earth, calling South Pole the extremity that pointed toward the north, and North Pole the extremity pointing toward the south. In the words of Sir David Brewster, Gilbert applies the term magnetic to all bodies which are acted upon by lodestones and magnets, in the same manner as they act upon each other, and he finds that all such bodies contain iron in some state or other. He considers the phenomena electricity as having a considerable resemblance to those of magnetism, though he points out the differences by which the two classes of phenomena are marked. To give here such an analysis as Gilbert's admirable work merits would be impracticable, but the short review of it made by Dr. John Robinson deserves full production as follows. In the introduction, he recounts all the knowledge of the ancients on the subject and their supine inattention to what was so entirely in their hands. And the impossibility of ever adding to the stock of useful knowledge, so long as men imagined themselves to be philosophizing, while they were only repeating a few cant words and the unmeaning phrases of the Aristotelian school. It is curious to mark the almost perfect sameness of Dr. Gilbert's sentiments and language with those of Lord Bacon. They both charge, in a peremptory manner, all those who pretend to inform others to give over their dialectic labors, which are nothing but ringing changes on a few trite truths, and many unfounded conjectures, and immediately to betake themselves to experiment. He has pursued this method on the subject of magnetism with wonderful ardor, and with equal genius and success, for Dr. Gilbert was possessed both of great ingenuity and a mind fitted for general views of things. The work contains a prodigious number and variety of observations and experiments, collected with sagacity from the writings of others, and instituted by himself with considerable expense and labor. It would indeed be a miracle if all Dr. Gilbert's general inferences were just, or all his experiments accurate. It was untrodden ground, but on the whole, this performance contains more real information than any writing of the age in which he lived, and is scarcely exceeded by any that has appeared since. We may hold it with justice as the first fruits of the Baconian or experimental philosophy. System of Mechanical Philosophy, London, 1822, page 209. This work of Dr. Gilbert's relates chiefly to the lodestone and what we call magnets, that is, pieces of steel which have acquired properties similar to those of the lodestone. But he extends the term magnetism and the epithet magnetic to all bodies which are affected by lodestones and magnets in a manner similar to that in which they affect each other. In the course of his investigations, indeed, he finds that these bodies are only such as contain iron in some state or other. And in providing this limitation, he mentions a great variety of phenomena which have a considerable resemblance to those which he allows to be magnetical, namely, those which he calls electrical, because they were produced in the same way that amber is made to attract and repel light bodies. He marks with care the distinctions between these and the characteristic phenomena of magnets. He seems to have known that all bodies may be made electrical, while ferruginous substances, ferruginous substances alone can be made magnetical. It is not saying too much of this work of Dr. Gilbert's to affirm, it is not saying too much of this work of Dr. Gilbert's to affirm that it contains almost everything that we know about magnetism. His unwearied diligence in searching every writing on the subject and in getting information from navigators, and his incessant occupation in experiments have left very few facts unknown to him. Note, Humboldt states that in Gilbert we do not find either the abstract expression electricitas or the barbarous word magnetismus introduced in the 18th century. Cosmos, 1849, Volume 2, page 726, note. We met with many things in the writings of posterior inquirers, some of them of high reputation, and we met with many things in the writings of posterior inquirers, some of them of high reputation, and of the present day, which are published and received as notable discoveries, but are contained in the rich collection of Dr. Gilbert. We by no means ascribe all this to mean plagiarism, although we know traders in experimental knowledge who are not free from this charge. We ascribe it to the general indolence of mankind, who do not take the trouble of consulting originals, where things are mixed with others which they do not want, or treated in a way and with a painful minuteness which are no longer in fashion. We earnestly recommend it to the perusal of the curious reader. He will, besides the philosophy, find more facts in it than in the 2 large folios of Scarella. The manner in which this great man arrived to discover so much of magnetical philosophy, and all the knowledge he got on this subject, we are told by Sir Kenelm Digby, was by forming a little lodestone into the shape of the earth, by which means he compassed a wonderful design, which was to make the whole globe of the earth maniable. For he found the properties of the whole earth in that little body, which he therefore called a terrella, our little earth, and which he could manage and try at his will. And in the like manner, any man that hath an aim to advance much in natural sciences must endeavor to draw the matter he inquireth of into some small model, or into some kind of manageable method, which he may turn and wind as he pleaseth. And then let him be sure, if he hath a competent understanding, that he will miss that, and let him be sure, if he hath a competent understanding, that he will not miss his mark. Amongst the many other ingenious contrivances frequently alluded to in his book, Gilbert mentions the versorium, an iron needle moving freely upon a point. With which he was enabled to measure excited electricity. Notes: Treatise of Bodies, 1645, Chapter 20, page 225. C. de Magnete, Book 1, Chapter 3. He is, he is, besides, the inventor of 2 most ingenious and necessary instruments for seamen, to find out thereby the latitude of any place upon sea or land in the darkest night, that is without the help of sun, moon, or star. These instruments are described in Thomas Blunderville's quarto work entitled The Theories of the 7 Planets, showing their diverse motions, printed at London, 1602. Of the monumental de Magnete, Professor Robinson. Of the Monumental de Magnete, Professor Robinson states that he knew of but 2 British editions and that he had seen 5 editions published in Germany and Holland before 1628. This would make 7 editions in all, if the 1600 Amsterdam edition which Cohen alludes to be included. Sir John Leslie, however, says that Gilbert's original work was republished at Ferrara in 1629 with a commentary by Cabeus. Thus are 8 distinct editions referred to, yet but 2 editions, 1600, 1633, are named by J.C. Brunet, Londini Sedini, J.C. Poggendorf, and International Encyclopedia, London Stettin, Algemene Encyclopedia and Biographie Universelle, London Sedan. 3 editions, 1600, 1628, 1633, are given by W.T. Lowndes, S.A. Allebonne, J.G.T. Rees, S.P. Thompson, Londini Sedini, Dr. J. Lamont Londini Stettin, British Museum Catalogue of Printed Books, London, 1888, Londini Sedani. 4 editions are alluded to at page 201 of the 1880 Catalogue of the Ronald's Library, edited by Alfred J. Frantz, viz. Londini 1600, Amsterdam 1600, Sedini 1628, 1633, and 5 editions appear in Mr. C. W. Cook's article as follows: London 1600, Stettin 1628, 1633, Frankfurt 1629, 1638, the same being specified in the 9th Britannica, with the difference that Sedan takes the place of Stettin. Notes: page 19 of the biographical memoir, Bibliotheca Britannica, Edinburgh, 1824, Volume 1, Authors, by R. Watt, pages 128 and 414. Edinburgh, Cyclop, article Gilbert, C. J.C. Poggendorf, Geschichte der Physik, Leipzig, 1878, page 279. 5th dissertation, Encyclopedia Britannica, page 741. Manuel du Libraire, Paris, 1861, volume 2, page 1592. Biography, Literature, Handwriting, Leipzig, 1863, volume 1, page 895. Volume 6, page 679, 1892 edition. Leipzig, 1858, section 1, page 229. Brussels, 1843 to 1847, volume 7, page 253. The Bibliothèque Manuelle, 1859, part 4, page 890. Critical Dictionary of English Literature, 1859, volume 1, page 668. Trésor des livres rares et précieux, 1862. The end of notes. Continuing. The other editions cannot be traced through any of the numerous catalogues of public and private libraries, or in the records of prominent sales at auction which have been consulted. The above has brought about the question as to the true significance of Sedini, with the result following. Sedan on the Meuse in France is given the Latin name Sedanum by Mr. Bercherel. Also, Sedanum in the dictionary George Bort, 1809, page 617, as well as by M. Bowen, Henry Cotton, and M. de Champs. Stettin on the Oder in Prussia is called in Latin Stettinum, dictionary George Port, 1809, page 652, M. Bowen, location citation, volume 1, page 701. C. Sedinum, likewise Sidini, Sudani, and Lexicon George, 1657, page 361. Dictionary George, or Dictionary George, Nice, 1791, page 301. Dictionary Geography, University, or Universal, 1832, pages 453 to 454, as well as by Leroux, Cotton, de Champs, W. Smith. Gilbert alludes to the Sudini of Prussia, Book 2, Chapter 2. Sedini, Sedinu, Seduni, Sedunum, French Sion, German Sitten, were names attaching to place and people along the banks of the Rhone River, in Switzerland. Philosophy Pretio Parallila Geographia, 1648, volume 1, page 347. Geography Long, Atlas of Class, Geography, 1874. Map 7, A.G. Finlay, Classical Atlas, 1853. Map 13, Alex McLean, Dictionary of American Geography, 1773. The Chumps Location Site, page 1161. As the French would say, il y en a un peu pour tous les goûts. But since Wolfgang Luckmann, the publisher of the editions, imprinted Sedini 1868 and 1633, was a resident of Stettin, J.C. Poggendorf, Biog Litter 100, 1863, volume 1, page 1484, the natural inference to be drawn is that the imprint Sedini stands for Stettin, and not for Sedan. In the present volume will be found photolithographic reproductions of 3 of the above named title pages. That of the 1600 Londini is taken from the copy of Mr. Charles L. Clark, whereto allusion is made hereafter, while the 1628 Sedini is reproduced from the copy in the library of the English Institute of Electrical Engineers, and the 1633 Sedini from the copy belonging to Dr. Park Benjamin of New York City. The 1628 is the most elaborate of all known Gilbert title pages, as described by Professor Sir William Thomson, Lord Kelvin. It is in the form of a monument, ornamented with commemorative illustrations of Gilbert's theory and experiments, and a fantastic indication of the earliest European mariner's compass, a floated lodestone, but floating in a bowl on the sea and left behind by the ship, sailing away from it. In the upper left-hand corner is to be seen Gilbert's terrella in orbis virtutis, or terrella in orbis virtutis. The terrella is a little globe of lodestone, which he made to illustrate his idea that the earth is a great globular magnet. The orbis virtutis is simply Gilbert's expression for what Faraday called the field of force, that is to say, the space round a magnet in which magnetic force is sensibly exerted on another magnet, as for instance a small needle properly placed for the test. Gilbert's word virtue expresses even more clearly than Faraday's word force the idea urged so finely by Faraday and proved so vividly by his magneto-optic experiments. That there is a real physical action of a magnet through all the space round it, though no other magnet be there to experience force and show its effects. The meaning of the little bars bordering the terrella is explained in Gilbert's book, where he alludes to the application of bits of fine iron wire as long as a barley corn, etc., etc. After the death of Queen Elizabeth I, March 24, 1608, Gilbert was continued in his position as royal physician by King James I, but he survived his benefactress only a few months. He died, some say, at Colchester, others at London, on the 30th November of the same year. He was buried in the chancel of the Church of the Holy Trinity in Colchester, where a monument was erected to him by his brothers, who placed upon it a Latin inscription, which appears at page 79 of Dr. Monk's Roll of the Royal College of Physicians. London, 1878. Dr. B. W. Richardson has translated the inscription as follows: Ambrose and William Gilbert have placed this tomb in memory of brotherly piety to William Gilbert, Senior, gentleman and doctor of medicine. This, the eldest son of Jerome Gilbert, gentleman, was born in the town of Colchester, studied the art of medicine at Cambridge, practiced the same for more than 30 years at London, with single credit and success. Hence called to court, he was received with highest favor by Queen Elizabeth, to whom and to her successor James he served as chief physician. He composed a book celebrated among foreigners concerning the magnet for nautical science. He died in the year of the human redemption, 1603, the last day of November, in the 63rd year of his age. The inscription is thus rendered by Thomas Wright at pages 310 to 311, volume 1 of his London, 1836, History and Topography of the County of Essex. Ambrose and William Gilbert erected this monument to William Gilbert, Sr., Esquire, and Doctor of Physics, in memory of his fraternal affection. He was the eldest son of Jerome Gilbert, Esquire, born in the town of Colchester, studied physics at Cambridge, and practiced at London more than 30 years with the great applause and equal success, and being sent for to court, he was received into the highest favor by Queen Elizabeth, to whom, as also to her successor James, he was principal physician. He wrote a book concerning the magnet, much celebrated by those engaged in nautical affairs. He died in the year of human redemption, 1603, on the last day of November, in the 63rd year of his age. An engraving of this monument from the notes is given in Philip Morant's History of Colchester, and it is described, Dictionary of Natural Biology, London, 1890, volume 21, page 338, as being a panel surrounded by a frame of Jacobean pattern surmounted by pinnacles, bearing globes and 14 shields of armoral achievements. Returning, Gilbert was never married. He bequeathed to the College of Physicians all the books in his library, his globes, instruments, and cabinets of minerals. These were unfortunately consumed in the great London fire of 1666. To the University of Oxford he left a portrait which he is said to have ordered made of himself for the purpose, and which was placed in the gallery over the schools. In this portrait, which is believed to have been destroyed, he appears standing in his doctor's robes, holding in his hand a globe inscribed terrella, whilst over his head is the inscription 1591 Aetatis 48, and a little below his left shoulder the words Magneticisque Virtutum primus indagator Gilbertus. The reader is shown in the front piece a copy of the only portrait of Gilbert known at this day. It was taken from Volume 2, page 33 of S. and E. Harding's Biographical Mirror, and is said to have been engraved by Clamp from an original picture in the Bodleian Library, Oxford. As will be seen, it lacks the inscription before spoken of, and represents Gilbert holding his hand upon an ordinary globe. It was the central portion of this picture which was utilized by Mr. Arthur Ackland Hunt for his well-known historical painting representing Gilbert making an experimental demonstration in electricity before Queen Elizabeth. Speaking of Gilbert, Dr. Fuller writes, "One saith of him that he was stoical, not cynical, which I understand reserved, but not morose, never married, purposely to be more beneficial to his brethren." Such his loyalty to the Queen that, as if unwilling to survive, he died in the same year with her, 1603. His stature was tall, complexion cheerful, and happiness not ordinary in so hard a student and retired a person. Besides Gilbert's folio de Magnete, there appeared at Amsterdam in 15 and besides Gilbert's folio de Magnete, there appeared at Amsterdam in 1651 a quarto volume of 316 pages entitled De Mundo Nostro Sublunari, Philosophia Nova, which was edited, some say, by his brother William Gilbert, Jr., according to others by the eminent English scholar and critic John Gunther, from 2 manuscripts found in the library of Sir William Boswell, Knight. According to Dr. John Davy, this work of Gilbert's, which is so little known, is a very remarkable one, both in style and matter, and there is a vigor and energy of expression belonging to it very suitable to its originality. Possessed of a more minute and practical knowledge of natural philosophy than Bacon, his opposition to the philosophy of the schools was more searching in particular, and at the same time probably little less efficient. In the opinion of Professor John Robison, De Mundo consists of an attempt to establish a new system of natural philosophy upon the ruins of the Aristotelian doctrine. We give an extract from the work in a footnote to the present translation of Gilbert's De Magnete, Book 6, Chapter 7, and also enabled to give a reproduction of the 1651 title page made through the courtesy of Dr. Park Benjamin. The only known writing of Gilbert in English is in the form of a letter dated 14th February, 1602, which appears at the end of William Barlow's Magnetical Advertisements, or Divers Observations Concerning the Lodestone, Quarto, London, 1616, and reads as follows. To the worshipful, my good friend, Mr. William Barlow, at Easton by Winchester, recommendations with many thanks for your pains and courtesies, for your diligence and inquiring, and finding divers good secrets. I pray proceed with double capping your lodestone you speak of. I shall be glad to see you, as you write. As any man, I will have any leisure, if it were a month, to confer with you. You have showed me more, and brought more light than any man have done. Sir, I will commend you to my Lord of Effingham. There is here a wise, learned man, a secretary of Venice. He came sent by that state, and was honorably received by her majesty. He brought me a Latin letter from a gentleman of Venice that is very well learned, whose name is Johannes Franciscus Sagredos. He is a great magnetical man, and writeth that he hath conferred with divers learned men of Venice, and with the readers of Padua, and reporteth wonderful liking of my book. You shall have a copy of the letter. Sir, I propose to adjoin an appendix of 6 or 8 sheets of paper to my book after a while. I am in hand with it of some new inventions, and I would have some of your experiments in your name and invention put into it, if you please, that you may be known for an argumenter of that art. So, for the time, in haste, I take my leave. The 12th of February. Your loving friend, W. Gilbert. His intention to print the short appendix was never carried into effect. Professor Sylvanus P. Thompson states, Gilbert of Colchester, London, 1891, page 40, that with the exception of a single doubtful inscription, ex dono auctoris, and a single copy of De Magnete, not a line of his, Gilbert's, handwriting is known to exist, unless his hand wrote the signature Ye President and Society at the end of a petition, preserved amongst the manuscripts in the British Museum, addressed by the Royal College of Physicians in 1596 to the Lords of the Privy Council, complaining of the exaction of the Lord Mayor and Alderman of London. It is pretty certain that, of the manuscript copy of De Mundo in the British Museum, is not in the author's handwriting, for in the Elsevier print there is a note stating that the author's original manuscript was partly in English. It is unfortunate that Professor Thompson's attention should not at the time have been called to the fact that Mr. Bernard Quaritch's rough list number 99 for September 1899 offered at page 80, number 747, a 1600 De Magnete presentation copy from the author, with inscription on title Dedit William Gilbertus John Sherwood Propris Manibus. This copy, which formerly belonged to Mr. William Constable, FRS, and FAS, is now the property of Mr. Chase L. Clark, CE, New York City, through whose courtesy the reproduction of the title bearing the inscription appears at page Roman numeral 3. A comparison of the writing in both inscriptions would prove interesting. Muhammad's tomb at Mecca is said largely to hang up, attracted by some invisible lodestone, but the memory of the doctor will never fall to the ground, which his incomparable book De Magnete will support to eternity. In his epistle to Dr. Walter Charleston, physician in ordinary to King Charles I, the celebrated English poet John Dryden predicts that Gilbert shall live till Lodestone cease to draw, or British fleets the boundless ocean awe. End of introduction. Contents: Translators Preface, Biographical Memoir, addressed by Edward Wright. Author's Preface, explanation of some terms in this work. Book 1, Chapter 1, Writings of Ancient and Modern Authors Concerning the Lodestone, Various Opinions and Delusions. Chapter 2, The Lodestone, What It Is, Its Discovery. Chapter 3, The Lodestone possesses parts differing in their natural powers, and has poles conspicuous for their properties. Chapter 4, Which pole is the North? How the North Pole is distinguished from the South Pole. Chapter 5, One lodestone appears to attract another in the natural position, but in the opposite position repels it and brings it to rights. Chapter 6, The lodestone attracts iron ore as well as the smelted metal. Chapter 7, What iron is. What its matter, its use. Chapter 8. In what countries and regions iron is produced. Chapter 9. Iron 1 attracts. Chapter 9. Iron ore attracts iron ore. Chapter 10. Iron ore has and acquires poles and arranges itself with reference to the Earth's poles. Chapter 11. Wrought iron, not magnetized by the lodestone, attracts iron. Chapter 12. A long piece of iron, even not magnetized, assumes a north and south direction. Chapter 13. Smelted iron has in itself fixed north and south parts, magnetic activity, verticity, and fixed vertices or poles. Chapter 16. Of other properties of the lodestone and of its medicinal virtue. Chapter 15. The medicinal power of the iron. Chapter 16. That lodestone and iron ore are the same, and that iron is obtained from both, like other metals from their ores, and that all magnetic properties exist through weaker, and all magnetic properties exist, though weaker, both in smelted iron and in iron ore. Chapter 16. That the terrestrial globe is magnetic and is a lodestone, and just as in our hands the lodestone possesses all the primary powers, forces of the earth, so the earth by reason of the same potencies lies ever in the same direction in the universe. Book 2 of Chapter 1 of Magnetic Movements. Chapter 2 of Magnetic Cohesion, and first of the attraction exerted by amber, or more properly, the attachment of bodies to amber. Chapter 3. Opinions of others concerning magnetic cohesion, which they call attraction. Chapter 4. Of the strength of a lodestone and its form, the cause of cohesion. Chapter 5. In what manner the energy inheres in the lodestone. Chapter 6. How magnetized iron and smaller lodestones conform to the terrella and to the earth itself, and are governed thereby. Chapter 7. Of the potency of the magnetic force, and of its spherical extension. Chapter 8. Of the geography of the earth and the terrella. Chapter 9. Of the equinoctial, of the equinoctial, once again, of the equinoctial circle of earth and terrella. Chapter 10. The earth's magnetic meridians. Chapter 11. Parallels. Chapter 12. The magnetic horizon. Chapter 13. Of the magnetic axis and poles. Chapter 14. Why the cohesion is stronger at the poles than in the parts between equator and pole, and the relative power of cohesion in different parts of the earth and the terrella. Chapter 15. The magnetic force imparted to iron is more apparent in an iron rod than in an iron sphere, or cube, or iron of any other shape. Chapter 16. That motion is produced by the magnetic force through solid bodies interposed, of the interposition of a plate of iron. Chapter 17. Of the iron helmet cap of the lodestone, wherewith it is armed at the pole to increase its energy, efficiency of the same. Chapter 18. An armed lodestone does not endow with greater force magnetized iron than does an unarmed one. An armed lodestone does not endow with greater force magnetized iron than does an unarmed one. Chapter 19. The unition is stronger with an armed lodestone. Heavier weights are thus lifted. The cohesion is not stronger, but commonly weaker. Chapter 20. That an armed magnet lifts another, and that one a third. This holds good, though there be less energy in the first. Chapter 21. That when paper or other medium is interposed, an armed lodestone does not lift more than one unarmed. Chapter 22. That an armed lodestone does not attract more than an unarmed one, and that the armed lodestone is more strongly united to the iron, is shown by means of an armed lodestone and a cylinder of polished iron. Chapter 23. The magnetic force makes motion toward union, and when united connects firmly. Chapter 24. That iron within the field of a lodestone hangs suspended in air, if on account of an obstacle it cannot come near. Chapter 25. Intensifying the lodestone's force. Chapter 26. Why the love of iron and lodestone appears greater than that of lodestone and lodestone. Or iron and iron when nigh a lodestone and within its field. Chapter 27. That the center of the magnetic force in the earth is the center of the earth, and in the terrella center. Chapter 28. That a lodestone does not attract to a fixed point or pole only, but to every part of a terrella, except the equinoctial circle. Chapter 29. Of difference of force dependent on quantity or mass. Chapter 30. The shape and the mass of an iron object are important in magnetic cohesions. Chapter 31. Of oblong and round stones. Chapter 32. Some problems and magnetic experiments on the cohesion and repulsion. Some problems and magnetic experiments on the cohesion and repulsion and regular movement of magnetic bodies. Chapter 33. On the difference in the ratio of strength and movement of cohesion within the sphere of influence. Chapter 34. Why a lodestone is of different power in its poles as well as in the north as in the south regions. Chapter 35. Of a perpetual motion engine actuated by the attraction of a lodestone, mentioned by authors. Chapter 36. How a strong lodestone may be recognized. Chapter 37. Uses of the lodestone as it affects iron. Chapter 38. Of the attractions of other bodies. Chapter 39. Of mutually repellent bodies. Book 3. Chapter 1. Of direction. Chapter 2. Directive or versorial force, which we call verticity, what it is, how it resides in the lodestone, and how it is acquired when not naturally produced. Chapter 3. How iron acquires verticity from the lodestone, and how this verticity is lost or altered. Chapter 4. Why magnetized iron takes opposite verticity, and why iron, touched by the true north side of the stone, moves to the earth's north. And when touched by the true south side to the earth's south, iron rubbed with the north point of the stone does not turn to the south, nor vice versa, as all writers of the Lodestone have erroneously thought. Chapter 5. of magnetizing stones of different shapes. Chapter 6. What seems to be a contrary movement of magnetic bodies is the regular tendency to union. Chapter 7. A determinate verticity and a directive power make magnetic bodies accord, and not an attractional or a repulsive force, nor a strong cohesion alone or unition. Chapter 8. Of disagreements between pieces of iron of the same pole of a lodestone, how they may come together and be conjoined. Chapter 9. Directional figures showing the varieties of rotation. Chapter 10. Of the mutation of verticity and magnetic properties, or of the alteration of the force awakened by the lodestone. Chapter 11. Of friction of iron with the mid parts of a lodestone between the poles, and at the equinoctial circle of a terrella. Chapter 11. Of friction of iron with the mid parts of a lodestone between the poles, and at the equinoctial circle of a terrella. Chapter 12. How verticity exists in all smelting iron, not excited by the lodestone. Chapter 13. Why no other bodies save the magnetic are imbued with verticity by friction with a lodestone, and why no body not magnetic can impart and awaken that force. Chapter 14. The position of a lodestone, now above, anon beneath, a magnetic body suspended in equilibrium, alters neither the force nor the verticity of the magnetic body. Chapter 15. The poles, equator, center are permanent and stable in the unbroken lodestone. When it is reduced to the size of a part taken away, they vary and occupy other positions. Chapter 16. If the south part of a lodestone have a part broken off, somewhat of power is taken away from the north part also. Chapter 17. Of the use of rotary needles and their advantages, how the directive iron rotary needles of sundials and the needles of the mariner's compass are to be rubbed with lodestone in order to acquire stronger verticity. Book 4, Chapter 1. Of variation. Chapter 2. That variation is due to inequality among the earth's elevations. Chapter 3. Variation is constant at a given place. Chapter 4. The arc of variation does not differ according to distance between places. Chapter 5. An island in ocean does not alter in variation, neither do mines of lodestone. Chapter 6. That variation and direction are due to the controlling force of the earth and the rotary magnetic nature, not by an attraction or a cohesion, or by other occult causes. Chapter 7. Why the variation due to this lateral cause is not greater than hitherto it has been observed to be, seldom appearing to amount to 2 points of the compass, except near the poles. Chapter 8. Of the construction of the common mariner's compass, and of the different compasses of various nations. Chapter 9. Whether terrestrial longitude can be found from variation. Chapter 10. Why in various places near the pole the variations are much ampler than in lower latitudes. Chapter 11. Cardin's error in seeking to determine the distance of the Earth's center from the center of the world by means of the lodestone in his De Proportionibus 5. Chapter 12. Of finding the amount of the variation, what the quantity is of the arc of the horizon from its Arctic or Antarctic intersection by a meridian to the point toward which the needle turns. Chapter 13. Observations made by seamen commonly vary and are untrustworthy, partly though mistakes and want of knowledge and the imperfectness of the instruments, and partly because the sea is seldom so calm, but shadows or lights may rest on the instruments. Chapter 14. Of the variation under the equinoctial line and thereby. Chapter 15. The variation of the magnetized needle in the Great Sea, Ethiopic and American below the equator. Chapter 16. Of the variation in Nova Zembla. Chapter 17. Variation in the South Sea. Chapter 18. Of the variation in the Mediterranean Sea. Chapter 19. The variation in the interior of the great continents. Chapter 20. The variation in the Eastern Ocean. Chapter 21. How the deviation of the needle is greater or less according to the distance of places. Book 5. Of the dip of the magnetic needle. Chapter 2. Diagram. Chapter 1. Of the dip of the magnetic needle, page 275. Chapter 2. Diagram showing dip of the magnetic needle in different positions of a sphere and horizons of the earth in which there is a variation of dip. Chapter 3. An instrument for showing by the action of a lodestone the degree of dip below the horizon in any latitude. Description of the instrument it uses. Chapter 4. Of a suitable length of needle on the terrella for showing the dip. Chapter 5. The dip is not caused by the attraction of a lodestone, but by its power of giving direction and rotation. Chapter 6. Of the ratio of the dip to latitude and the causes thereof. Chapter 7. Explanation of the diagram of the rotation of magnetized iron. Chapter 8. Diagram of the rotation of magnetized iron, showing the magnetic dip in all latitudes, and showing the latitude from the rotation and dip. Chapter 9. Demonstration of direction, or of variation from the true direction, together with dip, simply by the movement in water due to the power of controlling and rotating. Chapter 10. Of variation of dip. Chapter 11. Of the formal magnetic act spherically effused. Chapter 12. The magnetic force is animate, or imitates a soul. In many respects, it surpasses the human soul, while that is united to an organic body. Book 6. Chapter 1. Of the globe of Earth as a great lodestone. Chapter 2. The magnetic axis of the Earth remains invariable. Chapter 3. Of the daily magnetic revolution of the globes, as against the time-honored opinion of a premium mobile, a probable hypothesis. Chapter 4. That the earth hath a circular motion. Chapter 5. Arguments of those who deny the earth's motion, and refutation thereof. Chapter 6. Of the cause of the definite time of the total revolution of the earth. Chapter 7. Of the earth's primary magnetic nature, whereby her poles are made different from the poles of the ecliptic. Chapter 8. Of the precession of the equinoxes by reason of the magnetic movement of the earth's poles in the Arctic and Antarctic circle of the zodiac. Chapter 9. Of the anomaly of the precession of the equinoxes and of the obliquity of the zodiac.